Okay, Dr. Harris, this is Nathan and Jose here for our mid-project presentation for the floating point coprocessor. So far what we've done is we've created like the framework for the coprocessor just to implement the add instruction. So we have it separate from the main processor right now. That's going to be our next step, is like integrating those together and then finally adding in multiplying and dividing. So right now what we have is just we have a register file, we have the control unit, and then we have that sending it to the ALU to perform all the arithmetic operations. And then we have our wrapper file right now for the output on the DE2 board. So we have switch 0 controlling our clock, key 0 our reset, and then we have one instruction being fed in right now, and then we have the LEDs controlling that. So for the simulation right here, and we'll get to the DE2 board after. We have it reading in. We have just for testing right now. We have the registers hardwired, we have an initial block sending the values in for right now because we don't have it hooked up to the other processor. So this register is getting 31.5, and this one has 7.875, and then the result should be 39.375, which is in hexes this value right here. 421D8. 000.
Yeah.
So now we'll show you. We weren't really sure what to put on the DE2 board, so we just did the exponents. So Jose is going to compile that now, and he can talk about it.
So then pretty much all that we passed on to the laptop over here to be able to pretty much show you on the DE2 board is we only passed in 3 files, which is going to be the wrapper, but I had to rename it coprocessor just because of the way that I did the project. And then after that, here's the coprocessor and just pretty much the reg file. So then here is us compiling it. Yes.
You can hit cancel on that.
Oh.
Yeah, hit no on that.
There we go. So then right here we're compiling it. So what we're doing in this is just pretty much what we're trying to show is the exponents that we pretty much come up with. So what we did is we actually already pretty much tried it, but we're gonna run it again for you just so you can see. But right here, this separates both values. So this one is, I believe, no, this is RD1 and this is RD2. We've done our own calculations where RD1 is obviously an exponent of 2, and then RD2 has an exponent of 4. Now, the final product, the value, the result has an exponent of 5, which is 101.
Yeah, there's an overflow when they add it, so the exponent gets shifted, or one added to it.
Yeah, it takes quite a bit to compile. All right, so I just decided to pretty much cut that out. But now going back to running it, just so we can show you. Here it is, programmer, add file, coprocessor file, and restart. So it's gonna start it, and it's gonna reset.
It's still not good. Yeah.
There.
So after a couple clock cycles,
There
yeah,
it
it finishes.
So right there, we get the final result.
Yeah. So right now we have it. It's kind of inefficient right now with the clock cycles, but that's what we're gonna work on after this, with like integrating the two processors together.
Yeah, what we pretty much wanted to do is first that we wanted to test out that we were going in the right direction instead of just pretty much wasting our time just typing everything out, and then we find out that nothing is working. So this pretty much shows us that we have the right idea, and we'll pretty much go on from there. I hope you're pleased with our report.